Arden Labs, specializing in high-performance software consulting, training, staffing, and development. Module 10, Channels. You are now watching Lesson 10.2, Basic Patterns.
So we're going to look at a handful of more channel patterns, signaling patterns here. And these are great patterns because if you can learn these patterns, then you can really learn a lot about how to think about signaling and apply this stuff to your code. The very first pattern, very base pattern we're going to look at is called wait for result. And the idea of wait for result is we're going to launch another Go routine to do some work. And this Go routine already knows what work they need to do. Right? We're just going to launch them. We're going to ask the Go routine to do the work. We're going to wait for them to finish that work, and we're going to wait for that result. So let's take a look at that code. So on line 41, you see the function wait for result. And then on line 42, what you see is the channel operation. Now again, we're using that make call to make that channel of type string. Couple things here. You cannot use any sort of compact or literal construction for a channel because you can't initialize a channel with values. So the only way to put a channel in that open state is with make. Now you can see that we're using make chan space string. So what I really want to look at is we can look at it as make is constructing a channel that's unbuffered. So we can say here we're constructing an unbuffered channel. I know that primarily because there's no value being set right now in the make call. But again, I want to get back to our signaling semantics. So what I would rather say here is that we're making a channel with guarantees where we're going to signal with string data. These are the things that to me are important. Those behaviors are semantics. Channel, guarantees, signaling with string data. Now on line 44, you see me defining a literal function again. We're making the function call and we're using the keyword go. So there's our path of execution. There's our new Go routine going on. And to simulate the idea that this Go routine knows what work they're going to be performing, on line 45, we do a time.sleep with a random number generator on the duration. I don't want you using time.sleep in any production level code. I'm using it here just to simulate the ideas of unknown latency. So we have no idea how long this operation is going to take. It's going to be randomized. It's going to be that sleep, right? So we're waiting. Maybe we're waiting on a system call, waiting on a database, we're waiting on something. In the meantime, while that Go routine is off doing its work, I always want us to put us in the manager position. So we're always the one making the channel. We're always making the other Go routine. We're always going to be either waiting or sending something to the other Go routine. But we're, in this case, waiting for that Go routine on line 50. So 50 is showing you the unary receive operation on the channel. We get that channel variable. Remember, channel is a reference type. We're going to use those value semantics to move it around, pointer semantics on reading and writing. And we have the channel operation attached to the left-hand side of the channel. We're now blocked in a receive, but remember, this is a channel that gives us guarantees. So the send and receive have to come together, and the receiver happens before the send. So here we are, we're blocked on 50 waiting. How long are we waiting? We do not know. That's part of the guarantee. It's an unknown latency. So eventually this time.sleep finishes. The work is done, and that Go routine wants to now send us that result. So now line 46 comes together on the send. We can see the Go routine on line 46 performing the send. We're already here on the receive. The send and the receive come together, and we pull that data out of the channel. Nanoseconds before that receive happens, nanoseconds. Line 50 happens before line 46. And then we'll see some print statements here. Now, this is the important part of this code. The only guarantee in this code is the signaling semantic that the receive happens nanoseconds before the send. Once that operation is done, remember these Go routines are running in parallel, not just concurrently, but also in parallel. Each Go routine is going to have their own thread running on their own hardware thread. So we have to remember that we don't really know what order the print statements are going to come in. This is a big mistake a lot of people make when they're first learning multi-threaded software. They think, well, since the receive on line 50 happens before the send on line 46, we should see the print on line 51 happen before the print on line 47. That is not going to happen. Remember, it's happening nanoseconds before. At that point, those two lines of code are free to execute concurrently or out of order. And to show you this, I'm going to run this little function. So I'm going to come in here and we're going to build it. There it is. I'm going to run it. And on the very first run, it looks like that I'm correct, that the receive happened before the send, right? Like I'm telling you. But if I run this enough times, we should eventually see that the send happens before the receive, at least the output of it, right? We know that's not happening right now, literally. But at some point, there it is right there. We now saw that the send happened before the receive. And not that the send happened, right? The output of the send message just happened before the output of the receive. I had to run it a few times to get there, but that's the point. And this is why people get confused. They don't realize that the only guarantee is happening between line 46 and 50. So this is the wait for result pattern. We're going to use this in patterns like fan-out patterns, where we're just going to throw go-routines at a problem. Go-routines are already going to know the work they have to do, and we're going to wait. So great for these types of fan-out patterns, this wait for result.